This is our automatic screen. This displays both sides. This is side A and this is side B. The blue bar graph represents the torr gauge. Again, remember that we backfill the units with nitrogen at the end of the test so that when we disconnect the unit, there's no vacuum to pull the surrounding helium mixture into the hoses. We do not want to contaminate, by mistake, the internal circuit of the test system. The red indicator is a vacuum transducer that is in the high vacuum manifold. Right now that manifold is at 19 microns. Station B is not on. In the center is the analog output from the helium mass spectrometer. Right now, the mass spectrometer is, with background helium, is reading 1.3, 1.2, 1.3 times 10 to the minus 8 cc's per second squared of helium leak rate. In each of the far ends, you'll see a readout very similar, which is the unit, the value, the MasSpec detected in the unit associated with that side. In other words, this will be the recorded value for side A. This would be the recorded value for side B. Up in the top, we have an elapsed timer that times the complete cycle of the automatic cycle. There is a message display area, one that displays the message for the system, and then there's a message display for each side of the test A and B. What I'll do is I'll run through a test automatically. It'll happen very quick. This is a short test. It will all take place in 1 minute. You'll notice that our helium ratio is down at 1.5%. During the evacuation, helium will be brought into this chamber and it'll stop at 15%. So we hit our reset button before we start. You'll notice we're on our first rough evac active. Now we're doing our first nitrogen backfill. Again, that's to help in cleaning out the unit. Now we're into our first high evacuation cycle active. You remember we had to get down to 100 microns before we went into our extended. So we're in the large unit. Now we're in our extended time period for 15 seconds. As you can see, we're well below 100 microns. Now we're doing our first pressurized test. Now our final evacuation for 10 seconds. Now we're exposing the internal circuit of the coil to the helium mass spectrometer for 20 seconds. And that unit passed. As you can see, we're now up to our 15% helium mixture. Now, I have another leak standard, very similar to the one that we used on our pressure decay machine. This one, however, is a much smaller leak. This is a 1/10 of an ounce per year leak that we talked about, or it equates to 2 times 10 to the minus 5 cc's per second. Because this is our test coil, we have provided a position for this leak to be attached. And remember, all this is a capillary tube with a crushed hole. Okay, we'll do a reset and start. We're doing a rough evacuation, our nitrogen backfill, our second rough evacuation, and our first high evacuation. Again, this is to take the unit down to below 100 microns, where we perform our vacuum pressure decay test to make sure that this internal circuit and the helium test circuit has no leak. Again, the background helium readout right now is 1.5 times 10 to the minus 8. We're in our first pressure rise test. We do perform 3 rise tests. Our final evacuation for 10 seconds. Now we're exposed, and as soon as we reach that fail point, we isolate the MasSpec so that we no longer contaminate the MasSpec tube. So as you can see, the unit failed our leak test. And the reading at the time of failure was recorded at 8.12 times 10 to the minus 7. So it dropped almost 2 full decades from our background reading from the mass spectrometer. Now I'm going to take the leak standard off. Reset the unit. Go to our nitrogen backfill. Also, I want you to make sure at the end of the test you notice that the internal circuit of the unit is filled again with nitrogen up to 760,000 torr, which is approximately 1 atmosphere.